writing all this down, okay? But we started with algebraic proofs yesterday. Today we're kind of going to go more into geometric proofs and continue on with that. Well, just know, okay, geometry also uses numbers, variables, and operations, okay? And we've talked about segment lengths. We talked about angle values, okay? So we're going to kind of go into that today, okay? So there's just a helpful hint, okay? But let's look at an example together, okay? And remember those boxes that we drew yesterday with the statements column and the reasons column? So let's look at this one right here. We need to write a justification for each step of this line segment of NO. Okay, so go ahead, if you want to write that down, go ahead and draw it, write it down. All right, but you don't need your computers out, so you can close those. Yeah. We're not, no. Just wait. I know, we've solved this before. It's just saying it stops at N and O. Well, I think it's just saying that's the value of NO. So it just wrote that it's, yeah. No. Okay, so if we had this, does anyone remember how we were able to prove that NM plus MO equals NO? What was the word for that? Like what we wrote something that, like, how can we say NM plus MO equals NO? Yeah. Yeah? Oh, no. That would not be trans. No. A what? Yeah, what postulate? Yeah. No. What was that postulate we learned? Well, that's what a postulate is. But this is just segment addition postulate, okay? So that's what that is. So really that drawing is your given, and then we're able to say NO equals NM plus MO because that's the segment addition postulate. Well, then we had like angle addition postulate. All right, so with this, do we know the values of NO, NM, and MO? Do we know the values? Yeah. Okay. So what would our reasoning be for putting those in, plugging them in? Which property that we learned yesterday? One of those properties we learned yesterday. Yeah. No. Look at the words carefully. We're not distributing them. Huh? No. One of you might have said it. Oh, never mind. Starts with an S. Substitution. We're just substituting those values in. Okay? That's an example of substitution property. All right? We can put those values in because we know that's what those segments equal. Okay? If you wrote that as a statements and a reasons, don't forget to have your given, okay? Because this is your given. Yeah. That's segment addition postulate. The given is your image.
Yeah, do we have to put the letters for the given?
No, you can just have your image. Just know that's given. But if you put NO equals NM plus MO as a given too, that would be fine. Okay. Now if we're looking at this, all right, what do we think our next thing that we're going to do is? Yeah. So what is that doing? Well, yes, but what? We're just, simplifying. Okay. So that's just simplifying. That doesn't really need to be a step in your box, but feel free to. What would we do next to get x by itself? We can do addition, okay, but it does subtraction because it subtracts the 4x over. But if you did addition, that's fine as well. But there's an example where they subtracted the 4 over, all right, and they got negative 4 equals x minus 9. All right, but if you added 9 over first, that's fine as well, as long as we're going to get that answer correct. Yeah, so now that we have this, what do we have to do? Yeah, we have to add. So what are we adding? The 9. So what kind of property is that? Yeah, addition property. Okay. Then we have 5 equals x. Are we done? Perfect. Oh, yeah, we're done. Okay. So you see how we're just adding and explaining those steps? Because really, you guys know what you're doing here, but think of it as you're explaining to someone that has no idea what they're doing. Okay. They've never solved anything like this, and that's what you're doing, is you're giving those reasons on why that works. And you're explaining those statements. Okay? Do we all have this one written down? Understand this one? All right, let's look at one with angles. Let's look at this one. All right, and it already shows that first step. Okay, but that's the angle addition postulate. But go ahead and write that image down. All right, and look at what it gives us. All right, so what is our first step going to be here? Yeah. 16. Say it out loud. Yeah, we're going to substitute those values in. Okay, so there's substitution property, so it should look something just like that. All right, again, so we're just substituting just like the last one because we know all those values. Okay, and then after that, just make sure you simplify. Okay, so it should look something just like that. 8, it's right here. I think Cronin made it when she taught math. This? Oh, that's just showing it's this angle. Yeah, they'll have it in 2 angles. That one's a little curved, so it wouldn't count. Okay, now what would our next step be? Subtraction, what are we subtracting? Okay, so that's subtraction property. Are we done? Why not? Yeah, we can't have a negative x. So what do we do to get rid of the negative? No. You got to divide by -1, okay? Maybe you just flip them, but you got to explain that's dividing. Why does it say dividing? It's not multiplying. Sorry? We'll just divide by -1. I know it says multiplication property, but no, that is division. Okay. Do we have questions about those two? Okay. All right. Don't write this down, okay? This is reminding you what reflexive property is. Okay, so it's like it's congruent to itself. Symmetric is flipping it. Okay, and then transitive, that's when it's saying like if A equals B and B equals C, then A equals C. Okay, that's just what it would look like if it had some like congruent sign. So this is saying of congruence, so just know it works with segments as well. Now, here's the biggest thing, one thing that you need to know. Numbers are equal, figures are congruent. Because eventually when we get into some proofs, okay, we're going to have like a congruent or an equal sign, and we're going to need to change that. Because numbers are equal, figures are congruent. Okay, so we don't say segment EF is equal to segment EF. It would have to be EF is congruent to EF. That would be an example. Okay. All right, let's see if we can remember these. Identifying the property that justifies each statement. All right. Who can tell me what angle QRS is congruent to angle QRS? What property was that? That works as reflexive. Perfect. All right, Jordan, what do you think B? Symmetric. There you go. All right, what about the next one? Who can tell me what the next one is? Yeah. Transitive. Okay, what about the last one? Yeah. Yeah, this is also reflexive. Okay, perfect. All right, just make sure you're familiar with those properties, okay? Because you're going to need those properties. All right. Okay, go ahead and put your notes away.